Okay. So good afternoon, everybody. So we are going to discuss about multicast ABR. So the good thing is that since this morning we are talking about optimization, so multicast ABR it's also an optimization for ABR streaming. So we are going to talk about this and how we can deliver ABR, live ABR streaming with the same efficiency that we could have in broadcast. So to start, I will give you a very quick view about the OTT market, where we are right now. Then we are going to discuss about the case study with the World Cup 2018. I will give you a short background of ABR streaming because I'm pretty sure that everybody here know what is it ABR streaming since the presentation of Ali this morning. And then we will go in multicast ABR, the technology, and what do we need to do multicast ABR on top of ABR streaming, and some key benefits, some key features around that technology, and then a status on the multicast ABR regarding standardization and the market where we are right now. Oh, doesn't work. Oh, yes. So rapidly, I want to give you, because I'm not sure everybody is aware of who we are at Broadpeak. So we are a software company, and we are doing multi-screen delivery. We have some PCs to build your own CDN in your network. So this is where we are. So we are coming from the CDN world, and we are always looking for innovation to optimize the network to deliver ABR streaming with the best quality and with the best service as we can. So this is where we are. So a short view of the market around OTT streaming. So everybody knows that OTT streaming is gaining ground, and it's just the beginning. So this is why we need to find some new solution to optimize this network, and we are trying to find all together some new solution how we can optimize the ABR and the live delivery for multi-screen devices and for all over the world. And the World Cup is very good. It's a good case study because it's recent and we have a good number, and it's also a good case study because we won that World Cup. So, as a French, I'm very proud of that. So it's a good case study, it's true. But it's not only because we won, but because there is some very good records that we reach. For example, from Conviva, they have 400 million plays during the World Cup. Another number coming from BBC, we realize that it's not only plays, but for this kind of event, it's mostly live that we are delivering. So this is what we have to tackle, how we can optimize the live delivery for this kind of events. So this is really what we want to tackle. The last number is coming from Akamai. So they reach 22 terabytes of streaming during the World Cup. It's a peak of traffic during the World Cup. So it's a very huge peak of traffic. And since the last World Cup, it was in 2014, so Akamai reached 35%, more 35% of peak of traffic compared to the last World Cup. So we just see that we are at the beginning of that increase, and we need to find a solution to tackle that live streaming for this kind of event. But it worked actually. So Akamai, so they were able to deliver this kind of big bit rates. But we are just at the beginning again on what we want to reach. Probably we want to reach where we are at the broadcast today. Just to give you an example, only in China, they deliver 56 million sessions in broadcast, so simultaneous session. So we are talking here only about China. So this is what we do only in England with OTT streaming. So we are just at the beginning of the OTT streaming. So this is the first thing that we need to scale a lot on more a lot. But the other thing that, so it works, but at some point YouTube TV, so they had some failure. I hope nobody is here from YouTube, but so for YouTube TV, it doesn't work well during the semi-final, so they have an outage, and YouTube TV subscribers were not able to see that game. So that's why we need to find solution to make it more reliable and to make it more scalable. So rapidly, a short background of ABR streaming. So what is it, ABR streaming? So we're using broadband, we're using HTTP streaming, we're using it for telcos, it's for cable networks, and it's what we call OTT, so it's over-the-top streaming. So this is where we are, and we have a CDN today to optimize this kind of delivery. But if you try to think outside of that box, so we have some multicast technology that already exists, which is there, and we can leverage it to deliver this kind of streaming. We have also the satellite. We could help to deliver this kind of IP streaming, even if right now the satellite is used only for broadcast. They want to be part of that game to deliver IPTV stream. So we have to involve them in that game. And the other thing is right now we are thinking about end-to-end streaming. So it's from the end up to the end users. But we can probably think with a different way and to have a contribution link in the middle, and the end still be ABR. In the middle we have a contribution link, and then for the end users it's still ABR. So this is where we are to working on that contribution link, maybe to improve that contribution link and to make it more reliable and more scalable. And finally, maybe we can talk with the terrestrial vendors like ATSC 2.0. So this is what we just had during the last presentation. That okay, we can use as well this kind of delivery to help the scalability of ABR streaming. But what we don't want to lose is the features that we have in ABR streaming. So we have multiple profiles. So with multicast ABR, we still have this multiple profile mechanism. So we need to change the profile related to the resolution, related to the size of the screen, and to the Wi-Fi capacity, for example, which could be decreased at some point. So this is what we have to have. So we need to stay with these kind of features. And we need to reach multiple devices, multiple screens. So we are talking about PCs, smartphones, tablets, connected TV. So all these screens today that we need to target with ABR, we still need to target them with multicast ABR. And for that, so we need to handle all those protocols. So we are talking about Dash, HLS, smooth streaming, probably CMAF. So this is where we are with multicast ABR. So we need to work with all this kind of protocol to reach all the devices that we have right now in the market. And the other thing is multi-DRMs. And we know that we have different DRMs, so different mechanisms to encrypt the content. So we need to work with this multi-DRM as well. So this is where we are with multicast ABR. So it's not because we are using multicast ABR that we are not dealing with all these key features that we have today in ABR streaming. So how it works now? So we have a content in the ADM, and we have some users in the home, in the edge network, and we have a streamer or packager. And this is in ABR, so the content will go from the streamer up to the end users, and we have different playing sessions that are currently running simultaneously, and we have one connection from the streamer up to the end users. So this is HTTP streaming. So if we are talking now about multicast ABR, so what we need? So we need another piece, what we call multicast ABR streamer or sender. They depend on different words, but there are different words. We have as well the mABR receiver or mABR client that we put in the edge. And then we have a multicast controller. Then we are going to see how these pieces interact all together. I would say we have another pieces, what we call, this is more the analytic server that combine that gather all the report from the network to create dynamicity with this multicast ABR and to say, okay, we have a live which is popular now, so we have to deliver it using multicast. And maybe 2 days after this live will not be popular again, so we replace that live with another one. So that's why we need an analytic server to analyze the traffic and to say to the multicast controller that this live is becoming popular, so we have to deliver it using multicast. Then the multicast controller sends this information to the multicast streamer, and the multicast streamer will get in unicast this ABR streaming from the packager. And then what we are going to do here, so we are going to convert this unicast into a multicast. So we are going to see later what we are doing exactly, and we send this multicast in the network. And the multicast is there now, and what we are waiting now, we are waiting from a request from the end users. So the end users will request the mABR receiver. The mABR receiver will join this multicast and will convert this multicast back in unicast to stream to the end users. So you see that in the middle we have only one stream, even if we have, in that example, we have 3 sessions. So where we are doing scalability in the core network, even at some point in the edge network. So this is what we want to solve with multicast ABR, to create more scalability using multicast. And then if we try to zoom in a little bit in the technology, so again, we are using HTTP streaming. So we have IP, HTTP, and then we have different profile, video profile, audio profile, even data with subtitles and so on. So what we are doing here in the mABR receiver, sender, sorry, so we are going to generate multiple multicast, one per profile. And what we put in that multicast, we put one video profile. You see that we have one video profile 1, and we have this one here. And we leverage unicast, and we could put an optional RTP header, and then we need to use a file-based protocol. So we were talking about float, norm, root, or proprietary protocols. This is what we have at Broadpeak. But what we need, we just need to convert this file, this small chunk, over the multicast. And we can use file-based protocol like root, float, norm, or whatever the protocol. So this is what we need to convert this chunk up over the multicast. And then, when the end users request a session, so we join this multicast, and then in the mABR receiver, we convert it back in unicast. So we are able to stream only one profile to the end users. And if at some point the end users want to join another profile, so we are going to leave that multicast, and we are going to join another multicast to send it again to the player. So it's not because we are using multicast ABR that we are not able to change the profile and to adapt the profile related to the resolution or to the Wi-Fi capacity. And the good question is where we have to put, where we have to put this multicast receiver. So there is no good answer, I would say, because we can put it wherever you want, or wherever you can, actually. The first receiver could be a cache server. Let's say that you have a CDN already in place, and you have a lot of cache server in your network, and you want to leverage this hardware that you have in your network. But we can optimize the core network. Between your headend and your cache server, we can put this agent on your cache server and get the multicast. It means that we'll save a lot of bandwidth here in the core network. Then we can push this agent more in the building or in the resort and convert this multicast in unicast only in that building. This is what we can do. And we can push a little bit more this agent and put it directly in the home. And then we are going to leverage CPEs that you already have in the home. It could be the gateway, it could be the set-top box, it could be a new media server that you will put in the home. And again, the multicast will be from the headend up to that home. So this is where we are able to optimize the network. And maybe why not, we can put directly this agent in the application on your device. And it means that the multicast will go up to this application. So right now we know that all devices, they are connected using Wi-Fi. So we need to think about a good way to convey multicast over Wi-Fi to have this kind of use case, but technically it works. We can put this agent wherever we want. And the good thing is that the more we are able to put this agent in the network, the more bandwidth we are going to save. And in the same time, the cost we are going to save as well. So this is where we can put this mABR receiver. And it's not because we're using multicast that we have to take care about the quality of service for the end users. And everybody knows that multicast is not a reliable protocol, so we need to have some solution to correct the missing packets that we could have in the network. So the first solution is using FEC and to put extra packets in the multicast itself, and the mABR client will be able to correct this multicast and then to switch back in unicast to stream to the end users. So this is one solution that we have with multicast ABR. The second one is using RTP retry. So it means that we have to have RTP on the multicast, but we can use RTP retry to resend the packets that we are lost during in the network. And in that workflow, the mABR client will request all the missing packets to the retry server. On the retry server, we send back the packet to the client, and the client will be able to rebuild the chunk to send it to the player then. The last mechanism that we have, it's HTTP retry. So it's very similar to RTP retry, except that we can use HTTP servers that you already have in your CDNs. So we can leverage your CDN in place and get the content directly from that CDN in HTTP. And then the mechanism is the same. We're going to rebuild the chunk with the corrected packet and send it to the player. And another point that I want to share with you is related to latency, because so we are sure now that latency in OTT is very important. And I have a story because I was watching the final game at the French Alliance. There are 3 rooms there. One is the main room, it was a broadcast signal, and the 2 other room was OTT signal. And maybe 10 minutes after the beginning of the game, everybody was in the same room, because everybody wants to see at the same time. Nobody wants to be delayed compared to the broadcast signal. So latency is very important, and we have to tackle it. So what we have right now in the regular streaming, so we have standard packager, we have standard player, so the quality is good, but the latency is bad. So this is a bad thing that we have right now. So we could imagine that we have a low latency packager with small chunk, with what we have what we discussed this morning, and we have a low latency player as well. But it means that the quality could be bad because we are leveraging unicast network, and we all know that unicast network is not very predictable. So we could have some contortion point. It means that the quality could be decreased because your buffer is very low, so you will not be able to deliver the same quality that you have when you have a big buffer and you can ask again the packet, for example. So this is why the quality is not very good if you are in the unicast network. But the latency is good. So this is where we are. I mean, with multicast ABR, so we can benefit of the short packager and the short player, and because we're using multicast, the streaming is guaranteed. So we are sure that we are going to have the streaming coming from the network, which is not the case in unicast because the unicast is the best for streaming. In that case, the network is managed, and that's why we are sure that we are going to have the packets. And it means that we will have a good quality, and we will have a short latency. So this is what we can. This is how multicast ABR can help for latency to have good quality and good latency. So there is no trade-off with multicast ABR. And finally, so I want to finish with multicast ABR status on where we are and where we want to go. So first, we were the first one to have this kind of solution, what we used to call it nano CDN at the beginning. So we have an award for that. It was in 2012. So we know well that solution, and we know well that the market around this multicast ABR. And then in January 2016, so DVB, they have created a group around multicast ABR. Right now, the standardization is still in progress. So we have this January of the first release of the architecture, which is exactly this one. So with the sender, with the receiver, and with the controller. So this is exactly the same architecture. And we are part of that group. So we are involved in that group. We are helping a lot this group to develop this multicast ABR standard. And cable apps, so they have some guidelines. The last release is in October 2016. It's more for cable apps networks, and they have different implementation around multicast ABR, but the service is the same. They want to leverage multicast to deliver OTT streaming. And so finally, the last group, the last standardization group who is working on multicast ABR, it's SCTE. And they took over the guideline from cable apps, and a group has been created in April last year, and so they are working on that multicast ABR right now. So we are at the beginning of multicast ABR in terms of standardization, in terms of deployment. And I would say, so let's make mABR bigger together to try to scale correctly the live OTT. That's it.
We're running a little bit behind. We'll take one question and then we'll go for a break. Thomas, okay.
Yes. Thank you, very nice slides. I have one question that was discussed in DVB as well, and that's a bit stalling this. I want to understand, the discussion is that if you have this multicast to unicast conversion, you need to have a server, and very typically the clients today exclusively rely on HTTPS connection. So how do you basically get server certificates into your end client, and how do you get HTTPS working on this last mile? Because that seems to be something which is very blocking, and we had the same questions when MBMS was done, and I have no answer. So if you have an answer, I would be very grateful how you can do this.
Okay, so yeah, it's a good question. HTTPS is very important. So this is exactly where we differentiate with cable apps, for example. So we are not using a proxy, so we are not in the middle. We don't want to intercept any request. So we go first in the controller, and then we have redirection. So this is the first point, and that's why we can deal with HTTPS. And then related to the certificate, we need to have an agreement with the content provider to deliver their content and to be sure that the player will accept streaming to the client. So we need to have an agreement, but this is with multicast ABR. Anyway, we need to have an agreement with content provider because we need to have the multicast in the network, and that's why we need some agreement at some point. Yeah.
Okay, so it really means that the gateway needs to have a server certificate, and that needs to be, so it needs to be a very trusted gateway.
Yeah, true.
Okay. But you're not aware of any other solution, because that's kind of quite limiting, I think.
You mean to have the certificate?
Very limiting.
No, we can put a certificate in a gateway with a secure chip. I think there is no real difficulty to do that.
Okay.